The concept you're going to learn today, linear approximation, is actually something you already know from your calculus past. It's now just been given a fancy name and a fancy scenario. A linear approximation is really going to be based on your building a tangent line, which we've already done because you remember when we build a tangent line, you need a point and a slope. And then from there, you do your old y minus y equals mx minus x. It's a combination of algebra and getting a slope from a derivative. So it's going to end up being a tangent line, but applied to a real scenario. So let's read a made-up real scenario, if there is such a thing. I'll let you read this. And so here's what this is saying. It's saying we're getting garbage building up in a landfill, and eventually we're going to be at capacity. And for some reason, don't worry about why, we want to estimate that capacity time with a linear approximation, not the actual function. So with straight up pictures, it would kind of look like this. This black graph, that's my g of t. All right, and we're saying for some reason, at week 7, if we build a tangent line and extend that out, that's a better model for figuring out when we reach capacity. So technically that tangent line goes like this, but you don't care about that side because we're heading out into the future. And we're saying when would that tangent line or that linear approximation end up having a y value of 15, because that's when we're going to say this landfill is at capacity. So if we build that tangent line, we can use our calculator or algebra skills to figure out when it's at capacity. So here we go. Let's build a tangent line. To do that, I need a point and a slope. So what I would do, this would be a calculator yes question, I would put this function into my y equals screen, and from there I can use the value option to get the y value and the dy dx option to get the slope. In case you want to look at that, there's a lot going on there, but there is my function, and I can do second calc, choose my value. Oh, I screwed it up. It's graphing it. And I can plug in x equals 7, and now I get out my y value. The other thing I could have done is I could have also done the derivative at x equals 7, and I get out the 0.75. That was probably a little small for you to see clearly, but know that you should be able to get these values from the calculator. Now that I have the point and the slope, I can build my tangent line. I'm just doing algebra. Now this is messy and you might say I'm a little crazy to have that many decimals, but remember a final answer has to be accurate to 3 decimals. So if you round early, those rounding errors could compound and you end up missing a problem that you should be able to get. So this is an acceptable form, but since we're going to be doing extra stuff with this, I probably want to turn this into y equals mx plus b style. And then, because this is a linear approximation, I'm going to give it the honor of a more appropriate name. This is going to be L. I like to use L to stand for linear approximation. So it's the linear approximation over time of that capacity of the dump. So if I know now this equation, which is the equation of this red dotted line, I wonder when does it take on an altitude of 15? So I now go ahead and say 15 is my y value. What's the t that leads to that? You could solve that by hand, but I'm going to remind you that you have your calculator and that the calculator intersection tool is a great way to solve an equation. So hold on here a second. Okay, in my calculator, I have entered my linear approximation, my L of t. By the way, this is my original curvy function, and I don't care about that one anymore because I'm replacing it with this linear function. And then here's the graph y equals 15. That's when it's going to be at capacity. If I graph them, we can see visually that that spot is the time at which we would be capacity. And so I would go second, calc, and then I would choose the old intersect. And now I can go ahead and figure it out. First curve, I'm moving the turtle on the second one. And I end up with this little number down here that you can maybe or maybe not recognize, 16 point something. So my final answer is 16.788. Now I've rounded to 3 decimals for AP accuracy. And what that's basically saying is this intersection happened at 16.788. All right, so just know that linear approximation, I'm going to lower the zoom here a little. All right, linear approximation is nothing fancy. It's just building a tangent line and using your tangent line to make some sort of prediction instead of using the curvy function to make some sort of prediction. Easy peasy.